Okay, so today we're going to be looking at this MindForge paper.
Yeah.
Um, and it's about AI agents that can learn collaboratively, kind of like, like kids do.
Yeah. Like when they
Yeah.
play together, they kind of figure things out together.
Right, and they get better over time. Yeah.
Exactly. And this research uses Minecraft as a testing ground, which is kind of cool.
Yeah. I mean, Minecraft is like the perfect place to experiment with this kind of thing.
It really is. It's got all these complex tasks and challenges that really test an AI's abilities.
So how does this whole MindForge thing actually work?
Well, it builds on this earlier AI called Voyager.
Voyager. I've heard of that one.
So Voyager was this really impressive AI agent that could learn to play Minecraft using these things called large language models, or LLMs.
LLMs, right. Those are like the brains behind a lot of these AI systems.
Yeah, exactly. They give the AI the ability to understand language and learn from it.
So Voyager was basically a Minecraft pro, thanks to LLMs.
Pretty much. It could navigate the world, find resources, even learn new skills, all using those LLMs.
That's pretty amazing. So what's the catch? There's got to be a catch, right?
Well, the catch is that Voyager needed these really powerful closed LLMs like GPT-4 to pull off those amazing feats.
Ah, so the kind of AI that's not exactly readily available for the average person.
Exactly. And that's where things got a little tricky.
So what happens when you try to use the more common open source LLMs? The kind you might actually find in, a toy or something.
Well, that's where Voyager hit a wall. It struggled with even the simplest things, like collecting dirt.
Wait, seriously? Couldn't even collect dirt. That's like Minecraft 101.
I know, right? And there were two main reasons for this. First, Voyager started developing these false beliefs about the game. Like, it might think it needs a tool to collect dirt, which you don't in Minecraft. You can just break it with your hand.
So it was overthinking things.
Yeah, basically. And the second problem was that the code Voyager generated to actually do stuff in the game was often buggy. So even if it understood what to do, it couldn't translate that into action.
Gotcha. So Voyager was brilliant, but kind of a diva, needing the best of the best to function.
You could say that.
So that's where MindForge comes in.
Exactly. MindForge takes what Voyager started, but adds some key ingredients to overcome those limitations.
Okay, I'm intrigued. Lay it on me. What are these secret ingredients?
Well, the first ingredient is something called theory of mind.
Theory of mind. Sounds deep.
It is. It basically gives the AI the ability to understand what other agents believe and want, just like we do in social interactions.
Whoa, so they can kind of read each other's minds.
Not quite mind reading, but it gives them a sense of the other agent's intentions and goals.
That's pretty wild. Okay, what else did they add?
So the second ingredient is communication. They gave these MindForge agents the ability to actually talk to each other using natural language.
You're kidding. They can have conversations. That's incredible.
Yep. Just like you and I are talking right now. These agents can chat back and forth and share information.
Okay, my mind is officially blown.
Mm.
What's the third ingredient?
The third one is memory. And not just any kind of memory. They have different types of memory, like episodic memory, which is like remembering specific experiences, and semantic memory, which is like having general knowledge about the world.
So basically they're equipping these AI agents with the tools they need to actually learn and grow from their experiences.
Exactly. That's the whole idea behind MindForge, to create AI that can learn collaboratively just like humans do.
So what happens when you put these souped-up MindForge agents back in the Minecraft arena? Do they actually perform better?
That's the really exciting part. Remember how Voyager struggled with those open source LLMs?
Yeah, that was a bit of a letdown.
Well, guess what? MindForge agents powered by those same open source LLMs actually outperformed the original Voyager on those basic tasks.
Whoa, hold on. They did better with the less fancy AI. That's a game changer.
It is. It shows that collaboration can really make a difference even when you're working with less powerful AI.
Okay, so give me an example. How did this communication thing actually help them in the game?
So imagine you have one agent who's stuck trying to collect dirt because it thinks it needs a tool.
Right, like Voyager did.
Exactly. In MindForge, another agent might simply say something like, hey, you don't need a tool for that. Just break the dirt with your hand.
So they're literally giving each other tips.
Yep. And that simple piece of advice can completely change the first agent's understanding and lead to success.
That's amazing. It's like they're tutoring each other in real time.
That's a great analogy. And it highlights the power of communication and collaborative learning.
So did they just let the agents chat freely, or did they have some kind of structure to these conversations?
They actually tested two different types of learning. One was instructive, where a strong agent using GPT-4 helped a weak agent.
So like having a teacher and a student.
Right. And the other type was collaborative, where two equally weak agents learned together.
So like a study group situation.
Exactly.
I'm guessing the teacher-student scenario worked better.
You'd think so, right? But here's the twist. Collaborative learning, where those weak agents tried to figure things out on their own, wasn't as effective.
Really? Why not?
It kind of became a blind leading the blind situation. They might have ended up reinforcing each other's mistakes.
Ah, so even for AI, having a knowledgeable guide is important.
It really is. It highlights the role of expertise in learning.
So communication is key.
Yeah.
But how did they actually measure how effective it was?
They looked at the number of times the agents talked back and forth, and they found that the more they chatted, the better the weak agent got at completing tasks.
So it was all about that constant dialogue,
Yeah.
that back and forth exchange of information.
Exactly. It's like brainstorming, but with AI.
And they actually recorded these conversations. I'd love to see what that looks like.
They did. And it's actually fascinating to read through them. It's like watching a group of kids trying to figure something out together. You see them sharing information, correcting each other, and eventually succeeding through teamwork. It's pretty mind-blowing. And here's the really interesting thing about these weak agents. After they had collaborated with the expert, they could actually perform better on brand new tasks, ones they had never even seen before.
Really? So it wasn't just like they memorized the solution to one specific problem.
Exactly.
Yeah.
They were able to transfer the knowledge they gained to totally new situations.
So they were learning how to learn in a way,
Yeah, you could say that. And it all comes back to that semantic memory we talked about earlier.
like that general knowledge about the world.
Exactly. By collaborating with the expert, the weak agents were building up a deeper understanding of how things work in Minecraft, not just how to complete one specific task.
So that's how they were able to adapt to new challenges even without the expert there to guide them.
Precisely. It's like they were developing a kind of common sense about the game.
It's pretty amazing to think that AI can learn in such a sophisticated way.
It really is, and it opens up a whole world of possibilities, especially when you think about the potential for things like educational toys.
Yeah, imagine toys that can actually help kids learn by collaborating with them, almost like a little AI study buddy.
Exactly. MindForge gives us a glimpse into that future, a future where AI can learn not just from data or instructions, but from each other, just like humans do.
So how did they actually set up these experiments? Like, what was the environment like?
Well, they used the same Minecraft environment as the original Voyager research. They had this platform called MindDojo, which is specifically designed for building and testing AI agents in Minecraft.
So they were basically running these little AI experiments within the game world.
Exactly. And to manage all the different parts of the AI's architecture, they used a framework called LangChain.
LangChain. What's that?
You can think of it like a conductor, making sure all the different AI components are working together in harmony.
Gotcha. So they had the Minecraft world, the AI agents, and LangChain to orchestrate everything.
Right. And of course, they needed the LLMs, the language models that power the AI.
And they were specifically looking at open source LLMs, right? The kind you might find in a more accessible AI, like in a toy.
Exactly, because the goal was to see if they could achieve sophisticated learning using technology that's more readily available.
So did they just swap out GPT-4 and Voyager with these open source LLMs and see what happened?
They tried that, but unfortunately it didn't go so well.
Really? What happened?
The open-weight LLMs they tried just couldn't keep up with GPT-4. They struggled even with those basic tasks like collecting dirt and wood that GPT-4-powered Voyager had aced.
So it seems like those open source LLMs still have some catching up to do.
They do, but that's where MindForge comes in. It was designed to bridge that gap by enabling those less powerful LLMs to achieve similar results through collaboration.
So teamwork makes the dream work, even for AI.
Exactly. But before they jumped into the whole collaboration thing, they actually tried another approach to boost the performance of those open-weight LLMs.
So what do they do?
They experimented with a technique called parameter-efficient fine-tuning, or PEFT for short.
PEFT.
That sounds complicated.
It's a way to make a pre-trained LLM better at a specific task without having to retrain the entire model, which would be incredibly time-consuming and resource-intensive.
So they were basically trying to give those open source LLMs a crash course in Minecraft.
Exactly. They fed them information from the execution logs of the GPT-4 powered Voyager and even gave them access to the Minecraft wiki.
So they were trying to make them smarter by letting them study the expert and read the textbook.
Yeah, that was the idea, but unfortunately it didn't work as well as they hoped.
Really? So even with all that extra training, they still couldn't keep up with GPT-4.
Not quite. It seems like true learning requires more than just absorbing information.
It's about understanding and applying that knowledge.
Exactly. And that brings us to the real heart of MindForge, the collaborative learning part.
All right, let's talk collaboration. How did they actually set up the interactions between these agents? They used the in-game chat feature in Minecraft so that agents could actually exchange messages and information in plain English.
So they were literally chatting with each other in the game.
Yep, just like human players would. But to keep things focused, they had these communication rounds where each agent could only send a limited number of messages.
So it was like a turn-based conversation.
Right, it forced them to be strategic about what they said and how they communicated.
Makes sense. So they started with the instructive learning scenario, right? Where a strong agent helped a weak one.
Exactly. The strong agent powered by GPT-4 would act as a kind of mentor guiding the weak agent, which was using an open-weight LLM.
So like a master and apprentice situation.
Yeah, and the results were pretty impressive. The weak agents with the expert's guidance saw a major improvement in their performance.
For example.
Well, their success rate for gathering dirt jumped up to 66.6%, and for collecting wood, it was even higher at 70.8%.
That's a huge difference. So having that expert guidance really made a big impact.
It did, but they also wanted to see what would happen when two weak agents tried to learn together without any expert help.
Right. That was the collaborative learning scenario.
Exactly, and as you might expect, it wasn't quite as smooth sailing.
I bet those two weak agents had some interesting conversations.
They did, and sometimes it worked out well. They were able to help each other and figure things out together.
But not always, I'm guessing.
Right. Sometimes it turned into a bit of a blind leading the blind situation.
They probably ended up reinforcing each other's mistakes.
Exactly, and that highlights the importance of having some kind of expert knowledge or guidance in the learning process.
Even for AI, it seems like you can't just throw a bunch of agents together and expect them to magically become experts.
Right, you need some kind of scaffolding to support their learning.
So the instructive learning with the expert agent was definitely more effective.
It was, but the collaborative learning still had some value. It allowed the agents to practice their communication skills and develop a shared understanding of the game.
I'd love to hear some snippets of those conversations they had, like what did they actually say to each other?
So imagine a weak agent trying to chop down a tree. It might say something like, I'm trying to get this wood block, but it's not working. What am I doing wrong?
Okay, and what would the expert say to that?
The expert might respond with something like, okay, well, first tell me what tool you're using. Are you using an axe?
So it's trying to diagnose the problem by asking clarifying questions.
Exactly. And if the weak agent says, no, I'm just using my hand, the expert can then guide them towards crafting an axe or finding one in a nearby village.
It's like having a personal Minecraft coach right there in the game.
Right. And through these conversations, the agents are not only learning specific skills, but they're also building up a shared understanding of the game world.
It's like they're creating a mental map of Minecraft together.
That's a great way to put it. And the more they talk, the more detailed and accurate that map becomes.
So it's not just a one-time conversation that does the trick. It's the ongoing dialogue that really makes a difference.
Exactly. It's like the difference between a quick 5-minute explanation and a whole semester-long course.
So we've talked a lot about how these agents learn during these collaborative sessions. But what about after the collaboration is over? Can they actually use that knowledge in new situations?
That's a great question, and it's what makes this research so exciting. The researchers wanted to see if MindForge could help AI achieve lifelong learning, not just learn how to solve one specific problem.
So how do they test that? Did they just throw a bunch of new challenges at the agents after the collaboration?
They did. They had two main scenarios. First, they tested what they called post-collaboration learning, where the weak agent had to complete the same task again, but this time without any communication from the expert.
So it was like a final exam to see how much they had actually learned.
Exactly, and the results were encouraging. Even without the expert's guidance, the weak agent still showed improvement on those tasks they had initially struggled with.
So the learning wasn't just temporary. It actually stuck with them.
It did, which suggests that the collaborative learning experience had a lasting impact on their understanding of the game.
That's really impressive. But they didn't stop there, right? They wanted to see if the agents could go even further.
Right. They wanted to see if the agents could apply what they had learned to completely new situations. So they introduced a second scenario with out-of-distribution tasks, or ODE tasks for short.
ODE tasks. What are those?
These were tasks that the agent had never encountered before. Even during the collaborative learning phase, it was like throwing them a curveball to see if they could adapt.
So they were really pushing the boundaries of what the AI had learned.
Exactly, and the results were pretty remarkable. Even though the weak agent was facing something completely new, it was still able to use the general knowledge and skills it had picked up during the collaborative phase to figure things out.
So it wasn't just memorizing solutions. It was actually developing a deeper understanding that could be applied to new situations.
Right, it was learning how to learn, which is one of the hallmarks of true intelligence.
It's amazing to think that AI can learn in such a sophisticated way. It really opens up a whole world of possibilities.
It does. And it has huge implications for things like education, personalized learning, and even scientific discovery.
Imagine a world where AI systems can learn from each other, just like we do, becoming more knowledgeable and capable over time.
And it all starts with something as simple as teaching AI to play a game and learn from each other.
This has been an incredible deep dive. It's fascinating to see how researchers are taking inspiration from human psychology and social dynamics to create more intelligent and adaptable AI systems.
And it makes you wonder, what other aspects of human learning can we translate to the world of AI?
It's an exciting time to be following this field, that's for sure.
It really is. Who knows what amazing breakthroughs might be possible if we can unlock the full potential of collaborative learning for machines.
So until our next deep dive, keep exploring, keep asking questions, and keep learning, because who knows what incredible discoveries are waiting for us just around the corner.